One of the more common real-world problems that we see involves mixing different substances together. So, as an example, we make lemonade by combining lemon juice, sugar, and water. So this is the idea of mixture problems. For mixture problems, there's three real things that we need to deal with. The first thing, which we'll denote by X, is the amount of substance that we have dissolved. V is the volume of the solution, so the total amount of solution that we have. And C is the concentration of the substance. So let's see how these are related. The concentration is determined by the amount of substance dissolved over the volume, or another way we might want to use this formula is multiplying the concentration and the volume gives us the amount of substance dissolved. So let's look at some problems. Amanda has 2 bags of nut mixes. The first bag contains 62% peanuts and the other contains 15% peanuts. So to make a 13-pound bag of 45% peanuts, how much of each should Amanda use? Well, let's start by making a table of the information that we need and what we have. So here's our basic table. We have 2 bags and then the mixture. So let's fill in the information that we know. First off, we know that the first bag contains 62% peanuts and the other contains 15% peanuts, so those would be our concentrations. The next thing we know is that we want to make a 13-pound bag of 45% peanuts. So the mixture volume will be 13 and concentration will be 45%. So what about the rest of the table? What we're really looking for in this problem is the volume from bag 1 and bag 2 that we should use. So let's call that X. Since we need a total of 13 pounds, bag 2 would then be 13 minus X, the remainder to get us to 13 pounds. We also said previously that multiplying the volume by the concentration gives us the amount, so we can multiply across to get our amount values. So this tells us exactly how many peanuts are in these bags. So as an example for the mixture, we know it's a 13-pound bag that's 45% peanuts, so 0.45 times 13 tells us exactly how many peanuts are in there. The other thing that we really need is the idea that if I take the amount of peanuts that I'm adding from bag 1 plus the amount of peanuts I'm adding from bag 2, that should give us the amount of peanuts in the mixture. There's no peanuts being lost or none being added. So we can just add the amount from bag 1 plus the amount from bag 2 should be equal to the amount in the mixture. Now that we've done that, we have a basic equation to solve. So we can start solving. Let's start by distributing and getting rid of our parentheses. That gives us 0.62x plus 1.95 minus 0.015x is equal to 5.85. We can then combine like terms on the left-hand side. That then gives us 0.47x plus 1.95 is equal to 5.85. We then subtract 1.95 from both sides. That then gives us the 0.47x is equal to 3.9. We then divide both sides by 0.47. In rounding to one decimal place, we get 8.3 is X. So X was the amount from the first bag that we need. So we need 8.3 pounds from bag 1 and 4.7 pounds from bag 2. We can mix those together and we will get 13 pounds of a 45% peanut mix. Let's do one more example. David's trail mix was made by combining 11 pounds of peanuts that cost $3 per pound, 8 pounds of dried cranberries that cost $7 per pound, and 9 pounds of cashews that cost $5 per pound. So what is the cost per pound of the mixture? This one's slightly different than the last one, but it is also a mixture problem. So once again, let's start by organizing stuff in tables. So this time we're primarily concerned with the amount that we have, the volume, the cost of that, and then the total cost. So let's look at what we have. We know that we have 11 pounds of peanuts costing $3 per pound. We know we have 8 pounds of dried cranberries and they cost $7 per pound. We know we have 9 pounds of cashews and they cost $5 per pound. We also know that if we multiply the amount that we have by the cost per pound, we'll get the total cost. So we have a total of $33 worth of peanuts, $56 worth of cranberries, and $45 worth of cashews. So what about the mixture? The problem doesn't give us a direct volume for the mixture, but we can find that because all we're doing is adding the peanuts, the cranberries, and the cashews together. So we have a total of 28 pounds. The cost per pound is what we're looking for, so that will be X. And then we can get the total cost by multiplying 28 times X. The next step is to set up an equation. And for this, we're going to realize that buying the mixture should be the same as buying the peanuts, cranberries, and cashews. So we should be able to add their total cost, the 33, 56, and 45, and it should be equal to the total cost for the mixture. So we have 33 plus 56 plus 45 is equal to 28x. We can go ahead and add the terms on the left-hand side. And that gives us that 134 is equal to 28x. We can then divide both sides by 28. And that gives us that x is equal to 4.79. So the cost per pound for the mixture, $4.79.